Hello guys, welcome back to Math Zone African Motives. We are still on our revisions, and in this case, we are going to consider our factorization, whereas we are considering the cubic polynomials. So we need to know how to factorize such cubic polynomials. Remember, we managed to work out the long division on its own, the long division. We managed to work on this part separately. So let's say you do not understand the long division in terms of the factorization, you can consider what we refer to as the synthetic division, which is another way of factoring the cubic polynomials. All right, so what we are considering this time, I just want you guys to remain with the knowledge that you already have about the factor theorem. All right, I just want you to refer back to what we had before on our factor theorem. Remember, I said when you are given your function f of x, whatever that you have there, which is a cubic ax cubed plus bx squared plus cx plus d. The highest exponent being what? A 3, like that. That's a cubic polynomial. So I said from the factor theorem, when you are to consider terms or numbers that you're going to substitute into this expression in place of x, where you are going to obtain a 0, let's say if f of k is going to give us a 0, let's say it's f of k, f of a, whatever that you consider there. If you are to obtain a 0 from this, therefore, what it simply means is that x minus k is a what? Is a factor. It is a factor of what? The f of x, the function f of x that we are given. And in this consideration, when we are referring f of k, then it is equal to 0 like that. It is where the coefficient of x squared, which is our a, is equal to 1. So let us consider this as a condition when a is equal to what? To 1. All right, I'm going to show you when a is not equal to 1, let's say we've got other values like 2, 3, 4, and so on, how to determine the first factor from such. But when you are given the coefficient of x cubed as a 1, like the examples that we had on our long division, if you check, the coefficient of x cubed was a 1. That is where I was actually saying you consider the factors of what? Factors of D. These are the ones that you are supposed to substitute to obtain what? To obtain a 0. You just consider factors of what? Factors of D. But it can be a condition where A is not equal to 1. All right, I'm going to explain that one separately. So the factor theorem, if you are to consider it, it gives us a linear factor. This factor here, the highest exponent on our x is what? Is 1. So meaning to say, what we are obtaining here is what? Is a linear factor of this cubic function. It is a linear factor. All right. So if we are to consider back from our long division, remember when you add that factor x minus k into that f of x, then you obtain another factor here. Then we're going to say the x minus k and that factor that you've obtained. The factor that you're going to obtain here was what? A quadratic expression. You're obtaining a quadratic expression, which was ax squared plus bx plus what? Plus c. So that is where our synthetic division plays a role in determining the remaining factor, which is our quadratic expression, just like the long division. Just like the long division. So in our case, I want to use an example, how to use the synthetic division. All right, I'm going to explain that one using an example. Then you follow that to answer any question if you are to use what? The synthetic division. All right, so like I said, I'm going to express this with an example. Let's say we want to factorize, all right, x cubed minus x squared minus 5x minus 3. In this case, the coefficient of x cubed is what? Is 1. So meaning to say, you simply have to consider the constant, which is what? Minus 3, which is that constant. That is the one that you just need to consider in determining your factors. So the synthetic division, you use it after finding the first factor from this condition of your what? Your factor theorem. That part, you are going to use it direct as before, all right? We are not going to skip that part. We are going to look into that, all right? So you look at the constant term, since the coefficient of x cubed is 1, so you look into the constant term of the cubic expression and list its factors, all right? So what are the factors of what? Factors, all right? So here we're going to need factors of what? -3, which is our constant. So factors of -3, we have got positive and -1, positive and negative what? 3. Here we consider the constant, since here the coefficient of x cubed is 1, like I explained. So from these factors, the factor theorem, guys, is still applicable, like I said. All right, from the factors, our factor theorem is to be applied. So I'm going to try each of these factors of the constant, substitute back in place of x as before. All right, so this is what you're going to have. Let us start with a positive 1. F of 1 is equal to, in place of x, I'm going to put 1 there. So that's 1 to the exponent of 3 minus 1 to the exponent of 2 minus 5 times 1 minus 3. Simplify this on your calculator. All right, so just for the sake of revision, let us have our calculator here. 1 to the exponent of 3 minus, this is 1 to the exponent of 2. Oh, sorry for that. Just need to move aside, then subtract 1 to the exponent of 2 minus 5, open bracket, then put 1 inside, minus 3. So that was going to give us a -8. As we can see, it is not equal to 0. F of k is supposed to give us a 0 in order for us to have what? The first linear factor, the linear factor. So here we are not obtaining 8. So whatever that was going to happen from this value of what? 1 with the value of k, that is 1 in our case, which was going to give us x minus 1, is not a factor, this one. It is not a factor, since we are obtaining another value which is not 0. We are supposed to obtain exactly a 0. So try another one. It is actually, this part here, it is actually referred to as the trial and what? And error. You try values until you obtain what? A 0. So let us move on. We started with positive 1. Let us move on to -1. So that's f of -1. In place of x, just like before, put -1. So that's -1 here, squared, minus 5 times -1 minus 3. That's equal to what? Let us put -1. In place of x, we are going to put a -1. In place of x, we are going to put what? A -1. In place of x, let us put a -1 like this. And you can see that you are obtaining what? A 0. This is exactly the situation that we need of our factor theorem. So the value that gave us a 0 there, if we check, it is now x minus k. It was a positive, meaning to say if it is 2 giving us a 0, the factor will be x. You put a negative on that number, x minus 2. Take note. So if it is f of minus 2, which gave us a 0, it's going to be, you put a negative there to obtain the factor. So it will be x minus minus 2, which is actually x plus what? X plus 2. Do not forget the concept of your factor theorem. So this is what we have. We obtained a 0 from what? From a negative 1. So therefore, x minus what? Minus 1. X minus this value, which gave us a 0. X minus that is a factor, which is actually x plus what? X plus 1. So this is what? A factor. Is a factor of what? Our f of x, that function that you're given. So that is the condition of the what? Factor theorem. So there's no need for us to try 3 and minus 3, guys, from that. From the one that gave you a 0, you work with that one. If, let's say, you used a 3 or a minus 3, from that one, work from there. So this part here, guys, if you check, it is still the same as what we had before on our long division. The stage, this first stage, this one, of the first factor theorem is still the same. So whether you are using the long division, you are using the synthetic division, the part of the factor theorem has to be applied. In fact, in all the methods, we are going to have the last method, which is actually working with our algebra method. You see that factor theorem has to be applied for that one again. So each and every method, guys, please take note, factor theorem has to be applied. After that, that's where you use the method. The factor theorem, whether it is for long division, factor theorem is there. Synthetic division, factor theorem is there. The algebra method, factor theorem is there again. So meaning to say, after the factor theorem, that's where you start to consider the method now. So our method here is what? The synthetic division. All right. So factoring by synthetic division, guys, here, be very careful. By synthetic what? Division. Be very careful about the steps that we are going to take. All right, this is what you're going to need. We have determined the factor, which is our linear factor, from our factor theorem. Then, by synthetic division, you are going to take the f of x here as it is. This is your function, which is actually in the form ax cubed plus bx squared plus cx plus d. You are going to take the coefficients of each term, x cubed, x squared, x, and the constant d. All right, so this is what you're going to do. You formulate a table, which is going to need actually, let us see here, where you're going to need 1, 2, 3, 4, then 5. Let us just hope this is we're gonna win from this table, or I'm gonna need to add. All right, that's 1, 2, 3. I'm gonna need another one. All right, no problem. So this is it. You are going to need a table like this, where you are going to have the factors, coefficients, the constants A, B, C, and D of what? The cubic expression. So you're going to need those. All right, so you list them this way. This is your A, this is your B, this is your C, this is your D. These are the coefficients. These are the equivalent of those terms, or simply the constants, as we have got our cubic what expression. So A is equal to what? To 1. So in place of A, I'm going to put a 1. B is what? -1, the coefficient of x squared. So that's -1. Our C is what? -5, the coefficient of x. And D is the constant, which is -3. So this is how you apply your synthetic division. You take those from f of x. You take each and every constant that you see in that manner, A, B, C, D, like that. All right. Then you are going to consider the value of x, which gave us a 0. The value of x, remember from our f of x, f of -1, this is the x which gave us what? A 0. Not the factor. Long division, you took the factor x plus 1 into that f of x, all right? But as of the synthetic division, you take that value of x which gave you a 0. In our case, the value of x which gave us a 0 is what? -1. So this is how you apply that value of x in our table here. It follows that, all right? I think I've got so many, 1, 2, 3, all right? No problem. I'm just gonna ignore the last one, all right? So for the value of x that we have here, it is going to multiply values, that is its purpose, the value of x. But how do we multiply? I want you to understand first this part here that is going to happen. The value of a of the cubic expression that you had before, I mean this, the coefficient of x cubed, which is 1. When you are to divide by the factor x plus 1 that you're having here, it follows that it is the same value that you are going to have on the coefficient of x squared. Remember, when you are to divide by a linear factor, you are going to obtain a quadratic. After dividing, you're going to obtain this. So this coefficient of x squared, our a, is the same as the coefficient of, right? The coefficient of x cubed of what? The cubic expression. These two, they are the same whenever we are to apply our division. So meaning to say that if we have a 1 here, it means the coefficient of a of the quadratic, the one that you're going to have at the end, is going to be also a 1. It is also going to be a 1. So you're going to have that 1 here. All right. Sorry for that here. I just need to remove some of the parts of this table. It's going to affect me, or let me just do this. So that is the condition that you're going to have. The coefficient of x cubed and that of x squared are simply the same. They are what? The same. All right. Let us just remove some of this from our table. We just need actually 3. We just need 3 there, not this a lot like what we are having here. This is enough. All right, I just hope you're going to understand me here. The coefficient of what? X cubed is the same as that of x squared. If you are to take any part where we had a factorization, you're going to notice that after you've got your x cubed or whatever that you have, and this is the first factor, this part of ax squared plus bx plus c of the quadratic, you're having the same value, this value of a was the same as this one, which is 1. So it's going to be also a 1. So that is the consideration that I'm simply referring to say that whenever you are to obtain the quadratic, you simply have to apply from what? The cubic, the coefficient of what? X cubed and that of x squared. So this is our consideration now. With the value of x, you are going to multiply to that 1. All right, you multiply to 1. Whatever that you obtain, you write it corresponding like this. Take note how I'm multiplying. -1 times this, we write it in this part, in this box here. All right, take note that multiplication, guys. This is how you're going to multiply. So -1 times 1 is going to give us a -1. You multiply -1 times 1, you obtain a -1. So along this column, you add those terms. You are going to add -1 plus, all right, let me just have it here, -1 plus -1. You add them. -1 plus -1, which is going to give us a -2. You write it down here. You are adding along this column. So whatever that you obtain, you're going to write it down there. So -1 plus -1, that's a -2. All right, take note there. So the first part, you ignore this one. Ignore this because we need the last part. Or some, they use this, they write it here. Then when they multiply, they're going to put it here. It's one and the same, but you can just ignore them, write it at the end. Here, I want you to understand on the multiplication to say it's going to be this into this, all right? So that on the next one, since we are now having this 2 on the last row that we have, we're going to multiply again with the -1. So this time it's -1 multiplying a 2. Whatever that you're going to have, you write it in the corresponding box. Just like here, -1 times 1, you write to this one. So -1 times -2 into this box. All right? So let's multiply. -1 times -2 is going to be a +2. You add, just like here, you are going to add. So that's -5 plus 2. -5 plus what? 2, which is -3. Whatever that you're obtaining, you write it down. So that's a -3. Let's do this again. For this -3, from -1, you have to multiply. So it's going to be -1 multiplying 3. Whatever that you're obtaining, write it to the corresponding box, this one. So -1 times what? Times -3. That's a +3. It's going to be positive. Just like before, you add along the column. So that's -3 plus 3. -3 plus what? Plus 3. That's a 0. So this is going to give us a 0. Exactly what is supposed to happen. You are supposed to obtain a 0 on the last one, representing what? D. This part of D is supposed to give you a 0. If you obtain any other value which is not a 0, any other value which is not a 0, it means whatever that you said is a factor here is not a factor. This x plus 1 that you said is a factor, it's not. Or you made an error on your simplification, so you must cross-check on your calculations, one, to say the value of x that you substituted here, which is giving you a 0. It means there's an error on that value, or you made an error on these calculations. So you must be very careful. So you must obtain a 0 always on the last part. It must be a 0. So what is this presentation that I'm seeing in this box? It follows that these terms that we have here, 1, -2, -3, in this last row that we are having, these terms, 1, -2, and this -3, they represent A, B, C of the quadratic expression. A, B, and C of the quadratic expression. It means A of the quadratic expression is 1. So it's supposed to be 1x squared. Our B is -2, so that's -2x. Our C is what? Our C is -3. So the quadratic expression, sorry for that, the quadratic expression that we are going to have at the end is going to be simply 1. It was supposed 1x squared, which is simply x squared. All right. Bx, we said our B is what? -2. So that's -2x. Our C is what? -3. That's the quadratic expression obtained after dividing by the factor x plus 1. So meaning to say, this here, we must have x plus 1, the first factor, times what? This quadratic expression, which is the second factor. So we have got the first factor, and this is our second factor, which is a quadratic expression. The exact factor that you're going to obtain if you were going to use the long division, taking this x plus 1 into that x cubed, all right? You divide this the same way that we had x plus 1 into what? X cubed minus x squared minus 5x minus 3 like this. From that, you are going to obtain the same quadratic as this one that we have obtained. We're going to obtain the same quadratic expression here on top, x squared. All right, minus what? Minus 2x minus. This is what you're going to obtain. I want you to try your long division from those, for those who understand the long division. I want you to try and divide. You're going to see that this is the same quadratic expression that you are going to obtain, which is this one. So it means this is our f of x. From what we had from our original expression, this x cubed that we had, this one x cubed and this, it is giving us these two brackets. All right, our x cubed minus 5x squared minus 5x minus 3. It is giving us what? These two brackets. So this is your synthetic division. You have to use the factor theorem to find the first factor. Then using this table this way, you are going to have the second factor, which is the quadratic expression. By using the value of x, which gave us a 0. Take note, we are using the value of x on our multiplication there, which gave us what? A 0. So that is how you play around your synthetic division. So just like what we had previously, do not forget to what? To factorize the quadratic factor if possible. This quadratic factor, do not forget to what? To factorize it completely if possible. So in our case, let us check if this is possible. Minus 3, all right, this one is possible. So it was going to be x plus 1 into, we're going to have two brackets here. Factoring out the quadratic expression, we're going to need this part here, the coefficient, the constant term, the negative 3. All right, we're going to need this constant term, negative 3, factors of negative 3, which adds up to what? Negative 2. Factors of negative 3, and 1, 3 and negative 1. So which part, when we add, we are going to obtain what? When we add, we are going to obtain a negative 2. That's negative 3 and what? 1. So this was going to be x here, x here. Remember, this is 1. So minus what? Minus 3. And this is what? Plus 1. So you factorized this completely. All right. Yes, you can have this one and this one as a single bracket raised to the power of 2. All right. And the bracket of x minus 3. Yes, you can have that. But that is our factorization part using the synthetic division. So you see, guys, it is just a continuation. It's just a continuation from the factor theorem. What you need is to find the first factor. You must have the first factor, all right, just like before. Then you apply what? Your synthetic division concept. So that is the basic concept actually that you're going to have. In our case, you are going to, like I said, when the coefficient, like what you are given here for A is equal to 1, all right, if our A is equal to 1, you are going to look for what? You are going to look at the constant, actually at the constant term, which is our constant term of the what? Of the cubic expression, of the cubic expression, all right, of the cubic expression, which is what? Which is D in this case. The constant is what? Is D. So you look at that constant and list its factors, all right? And list its what? Its factors. List its factors. Those are the factors that you are going to substitute into what? Into the f of x to obtain what? To obtain a 0. So you're going to look for those factors, all right? Then substitute those, substitute, all right, the variable x. Okay, so we're going to substitute the variable x with factors of d, these ones that you had on the first part, all right? With factors of what? Factors of d until you find a value a value that gives as a result of 0, that gives a result of what? Of 0. So that is the condition that we had before. Then from there, you can actually use what? The factor theorem. So use the factor theorem now. Use the factor theorem to write down. So you're going to use the factor theorem to write down the first linear factor, to write down the first linear factor. The first factor, which is actually a linear factor. We saw that from our factor theorem, right? So that's the factor, the first linear factor of the expression of the given what? Of the given expression, which is our cubic expression. So that is the condition. Do not forget your factor theorem from the value that gave us a 0, that therefore x minus k is a what? Is a factor. So you must obtain a factor from there. That is the condition actually that you have your factor theorem. Then you apply or use your synthetic division. All right, then use the synthetic what? Division. Synthetic division. So this is applied, all right, to obtain the quadratic what? Factor. So that is to obtain the second factor. So use the synthetic division to obtain the what? The second factor. The second factor. Remember, we've got the first factor, and this second factor is a quadratic. It is a quadratic expression. It is not a linear, this one. It is going to give us a quadratic what? A quadratic expression. From that synthetic division, we saw that we are going to obtain a quadratic, just like what we had on our long division. We are going to obtain what? A quadratic expression, which is our second factor. And what are we supposed to do? To factorize that where possible, or where it is what? Applicable. You are supposed to factorize that. So do not forget to what? To factorize the what? The quadratic. Do not forget to factorize the quadratic factor. The quadratic factor, which is our quadratic expression, if what? If possible. So that's if what? If possible, do factorize that, because it is going to be, in our case here, it is going to be after this synthetic division, you're going to have the first factor and that quadratic ax squared plus bx plus what? Plus c. So where possible, this quadratic, please do what? Do factorize that. That is the condition of your factorization. You are supposed to factorize completely up to the last term, up to the last condition, where you have got what? 3 brackets, if possible. All right. Yes, sometimes there are other quadratic expressions where you cannot factorize further. In that case, you just have to leave your answer as it is. All right. So that is the example that we had. And from those notes, you can actually try to apply these steps. All right. So that is the condition. Find the first factor from this factor theorem, then use the synthetic division to obtain what? The second factor. All right, let us just try another example from what we have. We still need to factorize. All right, let us just try another one. Factorize. All right, factorize f of x, which is equal to x cubed minus 4x squared minus 11x plus what? Plus 30. All right, we need to factorize this. So just like before, the first thing is to apply our factor theorem. So we said to apply that factor theorem, since the value of a is equal to 1 on our cubic expression, the coefficient of x cubed is 1, you have to consider what? The constant, which is what? Positive 30. So you consider factors of what? Factors of what? Of 30. Plus or minus 1, plus or minus 2, plus or minus 3. So guys, there are so many factors. List those factors. Then try those factors. Which one is going to give us what? Is going to give us a 0. Of these, there are so many, you see, up to the last one. So substitute the variable x with the factors of d, which is our constant, which is this part. These are the factors. So you need to substitute that in place of x, f of 1, in place of x, 1 to the exponent of 3 minus 4 times 1 squared minus 11 times 1 plus 30. So you're going to see that this was not going to give us a 0. It's not going to give us a 0, this one. Let us try 1. All right, let me just have a bracket. 1 to the exponent of 3 minus 4 times 1 squared, like this, minus 11 into 1 plus 30. This is going to give us 16. That's not a 0, so we do not have a factor there. So you're going to try, guys. Minus 1 is not going to work. You try 2, all right? 2 was going to actually give us a 0. Let's just try 2 in place of x. 2 to the exponent of 3 minus 4, 2 squared minus 11 into 2 plus what? Plus 30. All right, let us try put 2 in place of x. Let us put a 2 here. All right, in place of x, let us put a 2 here and a 2 here. This is going to give us a 0. So that is where we have a factor. So therefore, from that value of what? Of 2. Remember, if it is f of k giving us a 0, x minus k is the factor. So we obtained a 0 from 2. So therefore, x minus what? Minus 2 is what? Is a factor of f of x, the original function that you are given. So that is the condition, guys. Then let us apply our synthetic division. All right, so apply or use what? Your synthetic division here. All right. So this part of our factor theorem, guys, is to be applied for any method. The factor theorem, you must understand it very clearly, this one. Then you can use your synthetic division, whatever method that you are going to use. All right, from the previous one, we saw that 4, they are enough. All right, these are gonna be enough. All right, no problem. This is going to be enough. Let me just write A, B, C, D. Remember, these are the constants from our f of x. All right, so our f of x here, we're going to take that A, B, C, D. So our A is 1, our B, C, and D like that. So A, that's 1, our B, -4, our C, -11, our D, that's what? 30. And using the value of x, which gave us a 0, the value of x, f of what? F of 2. So our x is equal to 2. From the f of 2, which gave us a 0, the value of x is the one that you're going to use. And remember what I said about the coefficient, this a of the cubic, it is going to be the same if we are dealing with that condition of a is equal to 1. It is going to be the same as that of what? Of the quadratic. So you just take the 1 as it is, you write it here as it is, all right? This 1 as it is. Then you can do the multiplication. Remember, the value of x multiplies 1, whatever that you're going to get, right, to this corresponding box. So that's 2 times 1, all right? You're multiplying here 2 times 1. That's a what? That's a 2, all right? Then what is that you do? You add along the column. You must add -4 plus what? -4 plus 2. That's a -2. All right. After that, as long as you've got the term here in the last row, you go back to that value of x, which is 2. You multiply 2 times what? 2 times -2. Whatever that you have, you're obtaining, you write it here. 2 times -2, that's what? -4. Then you are supposed to add -11 plus negative what? -4, like this. It is going to give us -15. All right, so that's -15 that you're going to have. And after obtaining this, you go back, guys, to your value of x. So x times what? X times negative, our 2 times negative 15, whatever that you obtain, you write it here. 2 times negative 15, that's a negative what? Negative 30. Along this column, you add. Do not forget, guys, you're supposed to add 30 plus minus 30. That's what? That's going to give us 30 minus 30, which is what? A 0. So this is a 0. Like I said, you are supposed to obtain a 0 on this last value, representing what? Representing our D, to show that exactly this value of 2 is giving us. If not, it means this is wrong. All right? It means the value of x that you substituted there is wrong, or your calculations along this table are actually what? Wrong. So this is what we have. And A, B, C, and D that we have remaining, this A corresponding to this one, and the B and the C here are what? The constant terms that we have on our quadratic expression, the ax squared plus bx plus what? C. So it follows that the factor that you obtained, all right, so therefore here, okay, let me just write that cubic as it was. Let me just write this one as it is, or I'm just going to write it as f of x, all right, so that we do not waste our time. So our f of x in this case is, or can be written as, the first linear factor x minus 2. The first factor that you obtained, x minus 2, times what? The second linear factor, which is, the second, which is our quadratic factor. Which is our quadratic factor. A is what? Is 1. Our A there corresponds to 1. So that's going to be 1x squared. So that's x squared. B is what? Our B is negative 2. So that's negative 2x. Our C, the constant, is what? Negative 15. These here that we have in this last row, that these terms A, B, and C, they are constants of our quadratic expression. So you have obtained a quadratic expression which you can factorize where possible. So can we factorize this? All right, let's try to factorize our quadratic expression. That's x minus 2 into 15. Yes, we're going to have factors here. So since this is 1, just going to have x and x here. Then consider the factors of the constant negative what? Negative 15, which will add up to negative 2. All right, factors of what? Negative 15, which will add up to negative 2. There's negative 5 and 3. All right, if you add this, you're going to get a negative 2. So that's negative 5 here plus 3. There are so many factors of negative 15, but we only need a condition. When we add, we are going to obtain what? We are going to obtain a negative 2. So that's our f of x here, factorized completely. This is what you're going to have. When it is what? Factorized completely, this f of x, this cubic expression that we had from our synthetic what? From our synthetic division. You just play around like that. Just like what we had on long division, it's just a matter of playing around, guys. You see, it's exactly from what we had, the steps that we had, to this and that. You see, guys, just a repetition. All right, so someone can ask you, say, okay, what about if we have got a negative on the coefficient of x cubed? Let's say that 1 there, it is what? It is a negative, like, all right, no problem. Let us consider last example. Then try as many questions as you can, all right? Just try as many questions, guys, as you can as an individual. So still on our factorization, let us try to factorize this, where our f of x is negative x cubed, all right? Negative x cubed, negative x squared plus x plus what? Plus 10. All right, let us try this one. All right, so I want you to try first, all right? Try it first using the synthetic division. Please try, then after that, follow these steps to see if you are on the right direction. All right, someone can factor out a negative first, of which you can ignore it, then factor it out at the end. You just follow those steps. finding the factors of what? Of the constant, so that you can apply the factor theorem, all right? So in our case, the constant here is 10. Dividing to this -1, guys, just -10. So just consider factors of what? Of 10 as it is. The minus here does not affect us at all. So we've got ±1, ±2, ±5, ±10. These are actually factors of what? Factors of 10. Then we try, guys, just like before, we are going to try which one is going to give us what? A 0. From these factors, we try +1, f of 1 in place of x minus 1 to the exponent of 3 minus 1 squared plus 1 plus what? Plus 10 in place of x. You're going to see that this is not going to give us a 0. But anyways, let us just do this for the sake of revision. That's -1 cubed, all right, minus 1 squared like this, plus 1, all right, plus 10. So this is what you had, and it's going to be a 9, not a 0. So there's no factor there. So I want you to try, guys, f of -1 again. If you're going to try this f of -1, it was not going to give us a 0. Try f of 2, all right? This was going to give us a 0, all right? In place of x, let us substitute 2 minus 2 cubed minus 2 squared plus, in place of x, you put a 2, all right, plus what? Plus a 10. All right, let us just see what you're going to have here. In place of x, that was going to be 2. So it's a trial and error. Try, guys, until you obtain what? Until you obtain a 0. Try each and every part until you obtain what? Until you obtain a 0. So you can see that f of 2 gives us what? F of 2 gives us a 0. So therefore, x minus 2 from the 2. If it was f of k giving us a 0, then we said this is a factor. So from +2, you're going to introduce a negative. Is a what? Is a factor. So that's the condition of what? Of our f of x that we are given here. So let us apply our synthetic division and determine the second factor, which is our quadratic factor from there. So this linear factor is our first factor that you've obtained. Then we can divide, all right? So there's no need actually of factoring out a negative. You can do that at the end, all right? So that is it. 1, 2, 3, 4. All right, let us see from here. So let us apply our synthetic division. Sorry for that. Synthetic division. We have to apply this one. All right, using the coefficient, the constants of our cubic expression, A, B, C, and D. We're gonna have them here, A, B, C, and what? And D. So our A, the coefficient of what? X cubed, which in our case here, we are given a negative. So it represents what? It represents negative what? -1. So our A is what? -1. Our B, just like here, it's a negative again, just like what we had. So it means it is what? -1 there. All right, there is a number there, which is 1. So that's -1. C, the coefficient of x. All right, the coefficient of x, as you can see, this is just a positive. So what is the number that we are given there? That's a 1. So we've got a +1 there. All right, so this is a +1. Then our D is what? The constant 10 as it is. So that is it. From what we are given, we are going to use the value of x. Remember, that gave us a 0. F of 2, which gave us a 0. That is the condition that we are going to use here. F of 2, which gave us a 0. It means the value of x there was what? Was 2, the one that gave us a 0. So this is it. Remember this concept, guys. -1 still remains there. So it's going to be -1 here. The A part, just drop the -1 down as it is. Then you multiply. All right. So remember the concept. You multiply here to get this. 2 times -1, that's -2. 2 times -1. Then what is that we do here? We add. Remember our concept. So let us add -1 plus -2. -1 plus -2. So that's going to be a negative here. So it's simply minus 1 minus 2, which is what? Negative 3. So we are going to have negative 3 here. All right. After that, we multiply, guys, just like before. 2 times what this time? 2 times negative 3. Whatever that we get, we're going to write it here. So 2 times negative 3, that's a negative what? A negative 6. Then we add, all right, just like what we had. 1 plus what? 1 plus minus 6. That's 1 minus 6. 1 plus minus 6. It simply means 1 minus 6, which is what? Negative 5. So this is going to give us a negative 5. All right. After this, you multiply 2. It's going to multiply what? Negative 5. So 2 is going to multiply negative 5, whatever that you get to write it here. 2 times negative 5, that's what? Negative 10. Add 10 plus minus 10, that's simply 10 minus 10, which is what? Which is a 0. Exactly what you must have here. You must obtain a 0 for what? For D. You must obtain a 0. And like I said, what is remaining in the last row, what we have here from our A, this is the coefficient of what? This is the coefficient of x squared. This is A, this is B, and this is what? And this is C of our quadratic what? Of our quadratic expression. So that is your f of x factorized. Is it can be written as the first factor, our linear factor of what? X minus 2 times the quadratic that you're obtaining here, ax squared plus bx plus what? C. What is our A? Negative 1. So that's negative x squared plus bx. Our B is what? Negative 3. So that's negative 3x. Our C is what? Negative 5. So that is what you're going to have at the end after factorizing. Then check if the last bracket, which is our quadratic, can be factorized. Yes, we can factor out a negative, this negative, negative, which is common. So you can write it as minus, all right? X minus 2 remains as it is. So minus and minus, that's positive x squared minus minus positive 3x minus minus positive 5. But can this be factorized? No, we cannot factorize this, guys. We do not have factors of 5, which adds up to what? Which adds up to 3. Factors of 5, that's 5 and 1, minus 5 and minus 1. Of these factors, none can be added to obtain what? A positive 3. So it means this is now fully factorized. We cannot factorize further this quadratic expression. That is why on our notes here, we had the statement that we are supposed to factorize the quadratic expression or the quadratic factor if possible. If it is possible, do factorize. But if not, then just leave it as it is. You have factorized fully that cubic expression. This one, the f of x, guys, is this cubic expression, this one. So you can even rewrite as it was here. Someone had to see it. You can even write as it was x minus x cubed minus x squared plus x plus what? Plus 10. What we had is equal to this. This is what exactly it means. Using the synthetic what? Division, you can factorize. Just like what you had on your long division. So it is your choice. It is in your hands because we have no questions actually where they are going to force you to say, use this, all right? Use long division, but you can actually decide which one is better to use or to apply from what we have so far, the synthetic division or the long division, but all the methods of factoring cubic polynomials will have to use in each and every method. You will have to apply the factor theorem. This is the key concept of your factorization of any cubic polynomial. So we are going to meet again in another class where we are going to actually consider another method of our factoring of the what? The cubic expressions that we had using the algebra method, where you can figure out like what can we say, by inspection using our algebra method. That's the last one that I'm going to explain. So from the three methods, you choose which one is the best for you. But for now, that is it. Till we meet again.